Okay, so we're going to talk about a new way to represent numbers. And you may have seen this before. It's something that's used pretty often in science classes. You may not have seen it yet, but you definitely will in the future. It's called scientific notation. So to fill in these blanks here, scientific notation is a compact, which compact means like very small, way of writing very large or very small numbers. And you'll see what that means as we move on. They tell us right here, a number written in scientific notation has the form a, where a is just a number, times 10 to the n, also another number, where a has to be between 1 and 10. That's what that means right there. It has to be greater than or equal to 1, or it has to be less than 10. So what that means is, let's scroll down here and look at what it means to convert a number to scientific notation. So if I'm starting with a number in standard form, a standard form number is just a number like you're used to seeing. Like number 1 down here has the number 540. If I'm changing that to scientific notation, step 1 up here tells me I have to move the decimal so the new number is between 1 or 10. So if I'm looking for the decimal point in number 1, 540, the decimal point is technically right there. It's hanging out at the end. They don't show it because it's kind of useless in standard form, but it's there. So if I'm moving, or if I'm changing something to scientific notation, first step says to move that decimal point. So what that means, if the decimal point is there, I'm going to move it until what I'm left with is a number between 1 and 10. So right there, I moved that decimal point. So the first part of scientific notation is 5.4. If I look back at what my form needs to look like in the end, I need to have that number multiplied by 10 to the something. That something, what that number is it's going to be raised to, is the number of times you moved the decimal point. So if we go back to our example of 540, I moved the decimal point 2 places to the left, so I'm going to put a 2 there. So going from standard form to scientific notation, 540 in standard form is 5.4 times 10 to the second power in scientific notation. What we did, we can fill out this first example up here. It says if the decimal point was moved to the left, the exponent is going to be positive. Because if you think about what this actually means, this means I am taking 5.4 and multiplying it by 10 to the second power. Well, we know that 10 to the second power, we just talked about square roots and perfect squares, that's actually multiplying by 100. And if you put this in your calculator, 5.4 times 100 gives you this 540. So that's my first example. Now, if I scroll down a little bit more, let's look at a little bit of a different example, like number 6. Actually, let's do one more like the one that we just did. Let's do number 3. So again, I'm going to follow my steps. The first step is that I got to get this thing looking like a number between 1 and 10. Find your decimal point first. Decimal point's right here at the end. If there is no decimal point, it's at the end. And then I'm going to start moving it. So I'm going to go here, 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 and there we go. Now I have a number between 1 and 10. That number is 1.852 times 10, and now I got to figure out how many times I moved the decimal point, where I started here, and I went over 1, 2, 3, 4, 5, 6 times. So that's going to be 1.852 times 10 to the 6. Okay, now if we look more towards the bottom here, there's some that look a little bit different. These are all already decimal points. I still am following the same steps. I still want this first part to look like a number between 1 and 10. So if I'm looking at, we'll look at the one that I just pointed to, number 6. My decimal point's right here. In order to move that, I have to go the opposite direction. And now I have a number between 1 and 10. It's 9.82. Still doing times 10. But things get a little bit different here, because if I start with a decimal, we're going to follow the second rule. If the decimal was moved to the right, like it was in number 6, instead of having a positive exponent, now I'm going to have a negative one. But I'm still doing the same thing. I'm still counting the number of spots that I had to move over. My decimal point here had to move over 1, 2, 3 places. So part of this is still going to be 3, but instead of a positive 3, now it's going to be negative. Okay, let's do one more. Let's look at number 9. So number 9, again, find your decimal point and start moving it so that it looks like a number between 1 and 10. Right there. I had to move it over one space, and my number is going to be 2.58. And then I only moved it over one space, but I went to the right, so it's negative 1. And you can do the same thing that you did up here with checking to see what this looks like in your calculator. If you put in your calculator 2.58 times 10 to the negative first, this is not something that we'll talk about too much, but in future math classes you will. 10 to the negative first is actually saying 1 over 10. Up here, 10 to the negative third, that's actually saying 1 over 1,000. So that's why that's why this is a negative number up there. So why don't you take a second, you can pause the video, and I want you to try the rest of the ones on this sheet. There's 1, 2, 3, 4, 5, 6 more, so pause and take a second to fill out those. Okay, now that you are back, let's just take a look at these 2 examples right here, and then we'll move on to the next page. They're asking us here to see if the number is correctly written in scientific notation, and if it's not, correct it. So what it's really asking you to do is look up at these rules at the top. The rules for scientific notation is that your first number part has to be between 1 and 10 times 10 to some other number. If I look at like number 11, we want to see if those rules are being followed. So I want to look at this part first, and that's good. That number's between 1 and 10. And this one, there's really no rhyme or reason to what that has to be, as long as this first part is correct. So for this one, I would say yes, it's correctly written in scientific notation. But then if I go over to number 12, look here, that is not correctly written in scientific notation. I need that decimal point to go over one more spot. And if I'm moving the decimal point over one more spot, instead of this being 10 to the third, that has to be 10 to the fourth. Now let's turn to the next page, and now we're going to go the opposite way. I'm going to go from scientific notation into standard form. I'm not going to start with a normal number. So this is actually, like it says up here, this is probably a little bit easier than the other way of doing it. So this is telling me that in scientific notation, this number is 6.38 times 10 to the third. So that means when I was switching it from standard form to scientific notation, I had moved my decimal point 3 places. So I'm going to do that. 1, 2, 3. Now my decimal point's at the end, so my standard form of that number is right there, 6,380. Let's try one more like that. We'll go down to, let's look at number 18. So number 18, again, I'm going to start with this number, 5.388. And they are telling me because of that 6 exponent, I need to move my decimal point 6 places. 1, 2, 3, 4, 5, 6. So now that I've got that, my actual number in standard form is there. And you want to throw some commas in to make it look like a normal number normally would. Excuse me. Now let's scroll down and do some with negative exponents because we know that those are a little bit different. Now remember what I've got, if I have a negative exponent in the end, in the beginning you had some sort of ugly decimal. So I'm going to start with this 5.25, but now instead of going to the right, I'm going to go to the left to get what that original decimal was. So I'll go 1, 2, 3, 4, 5. Wherever you move the space and it's just kind of blank area, that's where your zeros go. So your original looks like that. Let's try one more of these. So let's look at number 24. I'm going to start with that number part. And it's directing me, telling me that I had moved 2 spaces at some point. And remember, I want it, since I have negative here, I want it to look like a little bit of an ugly decimal beforehand. So I'm going to move 2 to the left. And my original standard form number was 0.06018. Pause the video again and take a second to fill in the rest of these, and then we'll move on. Okay, you should be back now. I just want to focus right now on these right here because the next activity you're going to do, or one of the next activities you're going to do, you're going to be using different numbers that we've looked at and comparing them using fractions, scientific notation, square roots. You're going to have to be able to recognize which ones are bigger, which ones are smaller. So let's take a look at this one first. All we have to do here to compare numbers, the easiest way to compare numbers is to make it look like a number that we're a little more comfortable with. We're probably not that comfortable with these just yet. So I want to turn both of them into numbers that I'm a little more comfortable looking at. So for number 25, for example, I have 7.42 times 10 to the third power. So that's telling me that I need to move 1, 2, 3 places to the right. Again, put a 0 in if you got any blank spaces. So this number is actually 7,420. I'm going to do the same thing with this guy over here. This one's telling me I have to move 5 places to the right. 1, 2, 3, 4, 5. Throw in some zeros where they belong. And again, throw in some commas just so it looks a little bit more like what we're used to. And now that's not too hard to tell which one's bigger. This one is 7,420. This one is 312,800. We know that that's bigger, so that's how I can compare those two numbers. So why don't you guys finish this up, do those last 3, and then we'll move on.